All right, so the basic idea behind these is that if I have a function of ax to the n, then the derivative is n times a x to the n minus 1. That's pretty simple. If y equals 4x to the third, then the derivative, which some people use this symbol for, is 3 times 4x to the 3 minus 1, which is 12x squared. So where did the 12 come from? The 3 times the 4. Where did the 2 come from? 3 minus 1. Now, if you have another function, the other type we're worried about, there's this number called e, which is kind of like pi. It's one of those things that you can't write easily. E to the x. The derivative of e to the x is, you're not going to believe how easy this is, e to the x. It's the function whose derivative is itself. So we're going to use those two ideas and look down here at these problems. This is, no, further, I forgot to say something. I probably should go back and say this. A constant does not change. So the derivative of a constant is 0. A constant is a number. How fast is 4 changing? Well, 4 is not changing. The derivative of a constant is 0. Nobody else is asking to join. I'm just double checking. Okay? So let's look at this one. This says y equals 2 to the 20th power. Well, I don't care what y is. I want to know how fast it's changing. And that's a constant. So the derivative of a constant is, guess what? 0. The derivative of a constant is 0. Now, this is also a constant because there's no x involved, or t, or whatever variable. There's no variable involved. That's a constant. The derivative of a constant is 0.
Yeah.
It's pretty easy, isn't it?
37 problems.
Pretty easy, isn't it? Here we go. This one, now, this was a little complicated simply because you don't see an exponent, but if you put that as x to the 1 power, now this part over here is a constant. What's the derivative of a constant?
0.
0. And when you multiply your 1 in front and subtract 1, you get 5.6 x to the 0 power, and a 0 power is simply 1, so you have 5.6 times 1, which is, guess what? 5.6.
All right, hold on 1 second. Right.
I'll stop. I'm going to pause. What's your question?
I'm just taking notes.
The idea is you have to write your variables as an exponent. Multiply it in front, subtract it. Multiply it. Now sometimes it's a fraction and you got to subtract 1, but still, multiply it in front, subtract 1. I'm going to erase that and go to the next one.
Hold
Okay,
on. Just like 1 second.
I'm going to freeze.
I just have to.
I understand. I'm going to freeze my computer screen. I'm going to see if anybody else is trying to join. I don't think they are, but I'm going to check. No, nobody else is trying to join. All right. So this next one works the same way.
Right. Yeah, these were.
Okay, tell me again.
I just looked at it and freaked out.
Okay. Multiply 2 in front and subtract 1. Make that be a 1 up there, and multiply 1 in front and subtract 1. And this becomes 18/8 x to the 1 power minus 3 x to the 0 power. And what's the derivative of a constant?
0.
0. Now, what's different about what I wrote and what the computer has? They reduced their fraction to lowest terms, and they took the 1 power off, and they made x to the 0 be 1. So the computer has 9/4 x minus 3. But that's the same answer. You can put in either one, actually. It'll take either one.
So 18.
Where'd I get the 18?
Yeah, the 2 times 9.
2 times 9. Where'd I get x to the 1?
So 1. 2 minus 1.
Right. Where'd I get no x over here? What happened to the x on the 3?
1 minus 1.
1 minus 1 is x to the 0. No
Minus
x's.
1.
Okay. Now later on we're going to discover a way to handle things that are being multiplied together, but right now we don't know that. So in this one you've got to do a little algebra first. You've got to distribute that and turn it into that. Are you okay with where I got all that?
Yeah, x squared and then 6x cubed.
All right. So my derivative is 2x to the 1
So we're going to write
minus 18x to the 2. And when it's x to the 1, you don't have to actually put it. You can just put 2x. The nice thing about looking at this as a teacher, they show you the steps.
Oh.
You don't see that.
I didn't even see that.
You don't see that, but I'm saying,
Yeah, I didn't see it just then.
yeah,
Either.
but I'll see that.
Yeah, that is nice.
And I may do mine different ways than they do theirs sometimes, but
I have to watch somebody do something.
now you've taken advantage of these watch it videos down here?
I have.
Okay,
I have.
because they're real good usually.
That's how I figured.
And also send me emails. I can make videos like this and send you the video.
Okay.
Okay, so let's look at this one. This is a little more complicated because you've got that fraction involved, but it's the same idea. I'm going to say negative 1/8 times 4 t to the negative 1/8 minus 1. That's x to a power, or t to a power. So I multiply in front, subtract 1. That's a perfectly fine answer like that. But they're going to simplify it all up and say negative 1/2 t to the negative 9/8. They're going to say negative 1/2 t to the negative 9/8. You know, if you had Mr. Staten, if you had taken him for calculus, he would tell you that calculus is nothing but a big algebra workout.
I took him for AP Cal.
And you saw you have the calculus is a tremendous algebraic workout. That's
Yes,
exactly what it is. Exactly what it is. Okay, so let's look at this. This is the same type of problem as long as I remember
So if you
that
flip
that says 8r to the negative 3.
Yeah.
And now it's the same type of problem. There is a rule about divided by. We haven't learned, you know that, the low high thing. You might have learned that, the quotient rule. You may remember that for AP anyway. So,
Vaguely.
what's my derivative? My derivative is negative 24, x to what power? R to what power?
Minus 1, negative 4.
Negative 4. What do most students put up there that gets it wrong? Negative 2. They subtract 1 from the 3, forgetting about the negative. That's not the way they wrote it in the book, but that's a fine answer. You can take it. They'll take it.
Or you can put the
Yeah.
R back on the bottom.
Yeah, either, what I'm telling you is WebAssign will take it either way.
Okay.
WebAssign will take it either way.
Okay.
Now there is a power rule, but we haven't learned that yet. So let's do some algebra first. If I FOIL this out, I have 25a squared plus 10a plus 1. And if you had Mr. Staten, you're probably real good at this, but some students may not be. All I did was FOIL that out.
Right.
That's algebra. No calculus involved. That's algebra. So my derivative is multiply the 2 in the front and subtract 1. 50a to the 1 power. Multiply the 1 in front and subtract 1, 10a to the 0 power. And how are they going to write that? 50a plus 10. Now, I hate that number 9 didn't have a watch it on it. I'm sorry about that. I tried to find one like it that did, and I couldn't. So I apologize for that. I try to make all of mine have a watch it if I can. But the trick here is do a little algebra and realize that that says t to the 1/3 power minus 3e to the t. That's just algebra. I've rewritten that third root, and if you don't remember how that works,
What's
Think
on
of
the thing goes on the bottom,
think of a tree. Where's the root?
at the bottom.
On the bottom. So the root goes on the bottom. Power goes on the top. The sun, the power goes on the top. The roots go on the bottom. Okay, so I'm going to multiply that in front and subtract 1. And e to the t is the easy one. What's the derivative of e to the t? E to the t. It's the easy one.
So you could put that, if you put it back into a.
Now, if you put it back in the thing, you put the t on the bottom
Right,
and have t to the 2/3 or t squared third root.
okay.
If you wanted to, yes. You could write that as 1/3 t squared third. It's kind of hard to fit all that in.
Yeah.
Third root of t squared 1/3 on the bottom, if you wanted to. But
And then,
you'll discover in your higher maths we don't put them back in radicals. Just leave them alone. I can do a whole lot more with the fractional exponent than I can do with the radical. That was a good skill to learn in high school because you will have, there are uses for it, but for what we're doing, yeah. Whoops, it's not what I meant to do, but that's okay. So, do a little algebra.
so it'll be x to the 1/3.
To the negative
To the negative 1/3.
1/3 because it's on the bottom. Remember, on a tree, the root goes on the bottom, the power, which is 1, goes on the top. So the derivative is 7 plus or minus, plus negative or minus positive, 2/3 x. When I subtract 1 from that, that's going to be negative 4/3. Remember to write your 1 as a fraction.
Right. So is ex 1?
E to the x,
No, no, no.
sorry, e to the x. I just left it off. E to the
Okay.
x is the easy one.
Right.
E to the x. E is the base for continual growth. You know, if something doubles every day, E lets you figure out what happens in between the doubling, after 5 minutes, after 10 minutes, after 30 minutes. Or the logarithm does. Okay, so again, we have a rule for division that we don't know yet. So I'm going to algebraically rewrite this as 8x to the 2 over x to the 1/2 plus 2x to the 1 over x to the 1/2 plus 4 over x to the 1/2. Remember that when you have a same denominator, you can split it up. And algebraically, it's not doing calculus yet, still doing algebra. This is 8x to the 3/2. Be careful there, you're subtracting your exponents. And 4 is just, 2 is just 4/2. Plus 2x to the 1/2 plus 4x to the negative 1/2. The thing that I always find confusing about the watch it videos is these guys are so good they'll take shortcuts
Yeah.
and assume you just saw
And
what
then
they
I'm just
did.
like,
Well, where'd that come from?
yeah.
What? 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 Stop. Go back. So I don't always complete the problems the way they complete them. So my derivative then becomes 24 halves x to the 1 half plus 2 halves x to the negative 1 half plus negative 4 halves x to the negative 3 halves.
2, 1, yeah, okay.
Make sure you see where all those come from. 3 times 8 is 24 halves. 2 times 1 is 2 halves. 4 times negative 1 is negative 4 halves. I would clean those up to be 12, 1, and negative 2.
Right.
I would not change my exponents. Now, the way they did it was they put the 1 half back in the square root. They put the negative 1 half on the bottom. And they realized this is negative 1 1/2, so they have 1x. That seems like a lot of extraneous work to me. So I'm just going to leave it like that. That's the way I would type my answer in.
12 x
12
plus x
12 x to the 1 half plus x to the negative 1 half minus 2x to the negative 3 halves. That's how I do mine. I make that be a 2 and a 1 and a 12. I'll leave everything else alone. That's how I do mine. And in the words of Mr. Staten, once again, tremendous algebraic workout. We don't have a rule for when it's x plus 8. We have a rule for when it's x, right?
Right.
But I can algebraically rewrite that as e to the x times e to the 8 plus 6. E to the 8 is just a constant, right? But it's times. It's times. So the derivative is e to the x times e to the 8. What's the derivative of 2e to the x? 2e to the x. What's the derivative of 3e to the x? 3e to the x. What's the derivative of e to the 8? E to the x. E to the 8, e to the x. I don't like that look. Let me stop. What's the derivative of 2e to the x? 2e to the x. That's a number. E to the 8 is just a number.
Oh,
There's no x in that, right?
right,
That's just a number. Like 5.
right.
12 is an ugly number. It's 2.1, 2.1718281828. I don't know what it is. It's like that. It's one of the, it looks like it repeats, but it doesn't really. 2.718281828, and then it goes off something.
So
What's
the,
a number times e to the x?
when you have it and when you rewrite the equation, is that e to the x times e to the 8?
Yes.
And then,
Which is the same as e to the 8 times e to the x, right?
okay. All
So
right.
the derivative is this. Another way to write that is, what do you do when you have a common base in your multiply? You add your exponents.
'Cause
Now, if that were 2x, it'd be different. Because then that would be e to the x squared, right?
yeah.
If that had been a 2x, that'd be e to the x squared. Because when you multiply exponents, you're raising the base to a power. And that's I tell you, what's Mr. Staten say? Calculus is a tremendous algebraic. They got a picture of him in his Tarzan suit, don't they? Doesn't he have one of those, like a picture of him in his little Tarzan suit with the lion thing, and he's
I think so.
lifting weights? Tremendous algebraic workout. Okay. So now I'm going to make every math teacher you've ever had angry. I'm going to show you the easiest way in the world to write the equation of a line.
Awesome.
I'm going to do y equals mx plus b, so quick and easy. Algebra lesson here real quick. If I have the point 3, 7, and a slope of 4. Now tell me what b is, not in this equation, but in general, what is b? In general, what does b stand for?
The y-intercept?
Which means y when x is
0.
0. So all I have to do is make x 0. Y equals 4x minus 3 plus 7. I've just written the equation of a line. Look at that. Boom. Let me do that again. What does that minus 3 do? Makes the x
Makes it 0.
0. I'm not doing calculus now. I'm doing algebra.
Wow.
Suppose I have the point 5, negative 2, and a slope of 2/3. then y equals 2/3. Make your x 0, x minus 5, minus 2. Now, what you might have seen in high school is y plus 2 equals 2/3 x minus 5. You know, do that in high school?
I
Just pull the 2 over and look what you have.
minus
It's, I know, 1,000 years ago, right?
It was six years ago.
Yeah, but that's one of the ways he teaches the equation, which is fine. But just pull your 2 over, you got.
Right.
So I do y equals mx supposed to be that way. It's quick and easy. I've lost my eraser. I know I have one someplace.
I don't see it.
What? I saw it. Usually I have 4 or 5 of them. I think the custodians have cleaned the buildings this weekend. So, looking at this problem, let's go back to this problem. Let's go back and look at how calculus concerns this problem. I know that I have y equals something times x minus 2 plus 22. Are you okay with that? I have the point 222, so y equals something, m, x minus 2 plus 22. What's the purpose of the x minus 2?
So we don't know the slope to make it 0.
We're going to find the slope.
Okay.
Guess what the slope is? The derivative.
Okay.
The slope is
The derivative.
the derivative. So my derivative of this problem is, be careful here, 9x squared minus 2x, right?
Because there we go. 2 turns to 0. 2 minus 1 is 1. Yeah.
And if x is 2, as it is at this point, then that becomes 36 minus 4. If x is 2, that's 9 times 4.
Yeah. So put 2 there. 36 minus, and then 32.
32.
But then you have to put the 32 into the.
Put the 32 right there. And the only difference between my answer and their answer is they went ahead and distributed the 32 times -2 and then added the positive 22 to it to clean it up to a nice number.
We don't have to do
You
all
don't have to do all that. If you wanted to, that's 32x minus 64, right? 32x minus 64 plus 22, which is that?
Okay. I'll just leave it simplified.
Okay?
Not simplified.
Unsimplified.
Normal. Yeah.
Unsimplified. Life's easy. Life's easy. Unsimplified. Okay, let's do another one. Same idea. It wants the equation of a tangent line, and I have the point 0,8. So y equals m times x minus 0 plus 8. And you don't have to put the x minus 0. I'm just doing it to get you in the habit of.
See. Okay, this one didn't have to watch it.
Sorry.
One of them, the watch it video, it just like, it wasn't this simple. I think I did the first one. I can't get into my account right now.
I'm sorry.
For some reason.
You mean to pause it?
Yeah, if you don't mind.
I don't mind in the least.
I will. All right. That's the, no, then we have to put that into.
Now, at this point, x is 0. So we plug a 0 in, and I have 8 times e to the 0. Anything to the 0 power is 1. So my derivative is 9 at that point. On that curve, at that point, the slope is
Wow.
9.
Okay.
Right? The slope is 9.
Okay.
So if I put a 9 in there, that gives me the equation of the line.
And we can leave it like that.
You can leave it like that, or just that's 9x plus 8.
Okay.
Same type problem down here. Remember, the derivative is a rate of change at an instant. Y equals mx minus 0 plus 4. And you know what may have happened? I may have meant to take the other one out because this is the same kind of problem with watching. So I may have meant to take the other one out and not thought I'd done it. But it's the same type problem.
Yeah. I
Okay.
was trying to do one of these.
Okay, so my derivative then is 4x to the third plus 4 e to the x. And if x is 0, that is 0 plus 4.
That's our derivative. And
So that's
then 0.
4. Now, what is a normal line? Well, let me give you an idea. If I had, let's say I was looking at a map, and these were different elevations right here. Have you ever seen like a map like that that has different elevations? Okay, so if I wanted to stay at the same height, I would have to travel along that line, right? And that would be the tangent line. If I wanted to go straight uphill, I'd have to go perpendicular to that line. And that's the normal line. The only difference between the tangent line and the normal line is that the slopes are negative reciprocals.
Oh,
That's the only difference between the tangent line and the normal line is their slopes are negative reciprocals.
okay, so normal line is a negative
It's perpendicular to,
reciprocal.
if you remember that from school, perpendicular lines have negative reciprocals. Their product is -1.
Alright, so it would be y equals
Negative 1/4 x minus 0 plus 4.
See, like, I guess whenever they do it in the problem, they skip all the steps of like showing.
They probably do. They probably do.
And they go straight to the answer, like negative 1/4 x plus 4, and I'm like,
That's what I'm saying. It's a whole lot easier face to face than online.
where'd they come from?
I know. It's like, believe me. All right, so let's look at this one. This one wants the first and the second derivative, and I like to explain that. Let's say my car is driving down the highway and speeding up. The first derivative tells me how fast I'm going at that instant. The second derivative tells me how fast I'm speeding up.
Okay.
So the first derivative is my change in position, and the second derivative is my change in velocity. So that's kind of an idea of what the second derivative can do. So algebraically, this is r to what power?
1/2.
Plus r to what power?
1/3.
So my derivative is 1/2 r to the negative 1/2 plus 1/3 r to the negative 1/3. And that's my first derivative. And both they and I wrote it the same way this time. We wrote ours the same way this time.
Right, so then the second derivative, how do you get that?
Take the derivative of that.
So you just do the negative 1/2 times 1/2.
Negative 1/4. Subtract 1 by subtracting 2 halves gives you negative 3 halves. Plus negative 1/9. And subtract 1 by subtracting 3/3 gives you negative 4/3. Whoops, 5/3. That should have been negative 2/3, shouldn't it? The first one should have been negative 2/3. I subtracted 3/3, that should be negative 2/3.
That's right.
That should be negative 2/3.
So you get 5. Negative
5/3.
5/3.
Negative 5/3. Negative 5/3.
Okay. So that's really not, okay. I was freaking out more than I should have.
Well, that's what I'm here for. Let's go to 17. Now this has got that graph thing on it, but let's go ahead and see. They're not asking you for an answer about the graph, so. All right, my derivative of e to the x is the easy one, e to the x, minus 8 x to the 7th. And the derivative of that is e to the x minus 56 e to the 6th. And if we look at a graph of e to the x minus e to the 8, which I'll take a second to do here. plot e to the x minus x to the 8.
Well,
What's that?
nothing.
You'll see that when x is 0, this is 1.
Okay.
And when x is 0, the slope is 1. It's hard to see that this is 1 because that's 1,000.
Yeah.
That's 1,000.
Yeah, right.
So I think that's kind of what they want you to see in this. I don't like that question.
Don't
Because
put it on the file.
Note that when the prime is run, it has a horizontal tangent line. Well, we can't see that.
Yeah.
You know, it's,
Yeah, it's so small.
yeah, you can't see that. So, but anyway. All right. They didn't ask any questions about that, so we're in good shape. So here's what we talked about. If this is my motion, my position, which physics books call S, I'm going to call P, is t third minus 27t. I've got a particle that's moving in some magnetic field, and that tells me where it is after t seconds. And I want to know how fast it's moving after t seconds. That's going to be the derivative.
Okay.
And if I want to know how fast it's speeding up, either positive or negative acceleration, that's the second derivative. So if the first equation is my position, the second equation is my velocity, and the third equation is my acceleration. On a side note, if you took physics
I've taken physics 1, 2, and 3.
or physical science, you will know that the position of an object in free fall is that negative 4.9 t squared plus the initial velocity times t plus the height. That's where an object is. Its velocity in free fall is negative 9.8 t plus your initial velocity. And the acceleration due to gravity is negative 9.8. I'm just showing you that it fits what we know about gravity, what Isaac Newton came up with about gravity. You know, there's my position, there's velocity, there's the acceleration.
Okay. So find acceleration after 30 seconds.
So plug a 3 in for acceleration, you get
Oh,
18.
18.
Plug in acceleration when velocity is velocity is 0. Now, not when time is 0, but when the velocity is 0.
So
Solve for that
0.
equals 0.
okay.
And you get either positive 3 or negative 3. Because you get t squared equals 9, right?
Right.
They're assuming t is positive.
Hold on.
Algebraically,
27 equals 30 t squared.
which means t squared equals 9, which means t could be positive or negative 3. But they're saying assume that it's positive, because we usually measure from some starting point forward.
So why do they have 18?
Because if t is 3, what's my acceleration?
18.
It didn't.
Oh, I see.
It says find acceleration when the
Okay.
velocity is 0. And that those two are the same could just be coincidence. I don't know if it is or not. If it were me, if I were writing the problem, I would make sure that those were not the same.
Right.
If I were writing the problem, but I didn't write the problem. So I know how to write the problems. I don't know how to make it accept any equivalent answer yet. I can write the problem so that it has to give the exact answer, but I don't know how to. Okay. All right, here we go. Another one. Another one bites the dust.
Okay. So 4, 0.
Multiply 1 in front, you get negative 1/3 t to the 0, which is,
1/3.
yeah, because anything to the 0 is 1. When you're working one of these, if you ask me for help, I don't know if it will say this on yours, but if it tell you a number over here, that would be helpful. See that 501
Okay.
XP?
Yes.
XP tells me this is from the extra practice session.
Okay.
I don't know if it'll show that on your screen
I
or
think
not.
it does. I
501 XP, 3.1, 501 XP. I know exactly what, because different students will have the problems in different order. Have you seen the Ask Your Teacher link?
Yes.
I'm not sure where it is, but it's somewhere.
I think it's somewhere like in that, up in that corner.
Yeah, I think it is.
All right, so
What's this one going to be?
let me,
I'm going to cover up my answer so you can't see it.
I didn't even look at the answer.
Covered it all up.
Okay. 2/3 x sub 6, so we're going to multiply 6, 2/3 x 6 minus 1 equals 4x sub 5.
Exactamundo. How about the one at the bottom?
Yeah, the way I was doing this, because I looked up videos too, it was much harder.
I don't know how you make this hard. I just don't. You know, the algebra ones I can see why those get, but I don't know how you make this one hard.
I have no idea. 5x to the 4th minus 9.
That's exactly what I got. Now let's look what they have. Yep, 5x to the 4th minus 9.
All right, go to the next.
Let's go to the next
Cover it up.
one. I got them covered up. We got 2 of them. Got to do some algebra on this one first. What's it going to say after you do your algebra? Foil it out.
Okay. Oh, wait, okay, I was looking for one at the bottom.
Okay, do the one on the bottom if you want to.
No, I got it.
Doesn't matter.
3x plus 2, so algebra.
You got to turn it into x to the n or e to the x. Once you have those, life's easy. Disconnect this.
So once you do the algebra, it should be 3x squared minus 13x minus 10. Is that right?
Right. So your derivative is, we have 3x squared.
6x1 minus 13.
All right. 6x
6x
minus 13. That's what we're saying. How about the one on the bottom? What algebra do you have to do before you can take the derivative?
I gotta bring that s up to the top.
Now it's got to be some number times s to the n, not divided by s to the n, but times s to the n. I don't like s's because we write 5s when I write them,
Yeah.
but
I don't see why they couldn't just do f of x for all of these. But
they really are gearing you for when you get to something where you're looking at change over time, you have a t,
okay.
or for a starting position, you have an
So
s.
just something different.
Yeah, well, you know, if you're going to use this, some people take this because they want to major in mathematics. Other people take this because they're majoring in something that's going to require physics as well. So they like to use variables that. On a side note, you know the letter I that we use for complex numbers, for imaginary numbers?
Mm-hmm.
In electrical engineering, they use a J because I stands for current.
Huh.
Look at that. Had an electrical engineer tell me that. I thought, that's cool. Interesting to know.
Okay, I don't know if this is right. Negative 7/2 s to the negative 3/4. Did I do
Okay.
anything wrong?
Nope, because you started off wrong. That's negative 14 s to the negative 4, not 1/4.
Oh,
S to the negative 4. A fourth root would have been 1/4.
Yeah.
So that's positive 56 s to the negative
now I see.
5. It wasn't that you did it wrong, just you started it off wrong. You were fine on the calculus.
Okay, wait. All right, so brings up. When it comes up, it's a negative 4.
Right.
Okay.
Roots are the ones that are fractions.
Okay, right.
Radicals are roots. Make them fractions.
Okay, so negative 4.
And negative times negative is positive.
Positive, and then the negative 4 minus 1 is negative 5.
And all they did for their answer was put it back on the bottom, make it s to the positive 5. I'd be perfectly happy. 56s to the negative 5, it'll take it.
Okay.
Let's just do that for fun. Whoops.
Okay.
There's some way I can submit that for testing. There ought to be. Oh well.
Will it not let you do it?
Yeah, there ought to be some way I can do that. I just don't see how to do it. So anyway, let's see if I can do it this way. Yeah. I think when I'm designing the problems, I can. When I'm creating the assignments, I can. Anyway, that's fine. Okay, so now this has the radicals, right? So this is t to the what power? It's a fifth
1/5.
root,
1/5.
1/5. And
then-
this is the square root,
Okay, so you're gonna put
2 on the bottom, and 5. I'm gonna stop there for a second. Put 2 on the bottom,
it's a 1/2.
it's a 1/2 power. Remember, the square root is you may not see it, there's a little 2 right there, right?
Right.
And if I had written this problem, I would make darn sure the number in front here was not 2.
Right.
So you wouldn't get
That's-
confused about which
I
was
was
which.
looking at it.
If I had written that problem, but I didn't write that problem, so I would say that number in front is not going to be a 2.
Okay, so 1/5 t minus 5/5 is -4/5,
Right?
and then plus
10 halves, right? Which is
Yeah.
5.
So 5t
Minus 3 halves is, minus 2 halves, I mean,
yeah,
is 3
minus
halves.
2 over 2 is 3/2.
There you go.
Okay.
All right, 25. 25. That's going to be 4x to the third, taking the derivative. We're doing calculus now. 16x minus 1, where x is 1.
So would you do,
Now, what is
Yeah.
19? It's the slope,
it's in,
right? It's the derivative. It's the rate of change at an instant. So the point, which is 1/8, gives me an equation of y equals m adjusted x to make it 0 plus 8.
16.
And if you clean that up, you get -19 and positive 8, which gives you the 11 on the end that they have. But that's a good answer right there.
So y equals the m
Adjusted x
minus
plus
x.
b, right?
So you do x minus x, so x minus whatever x is.
Now, if that had been a -1, how would I make it 0? Plus 1.
Plus
If that had been a -5 for the x, how do you make it 0? Plus 5. Because that b number is what happens when x is 0. So if x is not 0, I can adjust it. 26 is just a flat derivative problem. Multiply the 6 in front, subtract 1, you get 6/8.
Okay, let's go to 27.
Let's go to 27. Is there, you see the x's on that or t's on that?
No, so it's 0.
That's a constant. 0. Multiply the 2/3 in front and subtract 1. Negative
And
2/3.
they just put it back on the bottom.
X to the subtract 3/3, negative 5/3. They just put it on the bottom.
And then,
They put the x on the bottom, then the 3 was already on the bottom, right?
right,
Yeah.
right, because of the 2/3.
Yeah.
So if you did the derivative of that, it's going to be,
Positive 10/9, x to the negative 8/3, right? Yeah, I'm talking about number 28. Are you talking about a different one?
yeah, I was looking at the next one.
I was saying if you did the derivative,
Yeah.
if you did the derivative of that,
Yeah.
yeah, I'm sorry, yes. Next
I was-
one, 8 e to the x
Either
plus 0.
Yeah. So-
Negative 6/3 and subtract 3/3. See, that's what I don't, notice sometimes This one, they put it back on the bottom. This one, they didn't.
Yeah.
You know, they
I
got-
guess they're just trying to like show you both ways.
Well, we know they had different people doing different problems. You know, they'll send these books out to people, and I know people that have done this, and they'll pay a lot of money, but it takes like a year. You have to work every problem in the book looking for a mistake. And so
Wow.
they'll pay you money to do it, but
I'm sure they will.
because they want their first edition, you know it's going to have mistakes in the answer key, but they want to reduce the number one. So
All right, so I think I'm good on these.
I don't see anything that we haven't covered. This one you got to do some algebra first.
Which one?
Number 33, you're going to have 5x to the 2 over what?
Over 6x.
Plus 3x to the
1/2
over.
6x.
And what do you do with your exponents when you're dividing?
You subtract them.
So 5, 6x to the 1 plus 1/2. Now 1/2 minus 1 is x to the negative 1/2, isn't it?
Yeah. And then just take the.
That's it.
Yeah.
Take the derivative. You know. Now this next one may be a little confusing, but it's what we talked about, the application type problem. So if this is my function, then my velocity, my speed is 60x to the 14th minus 21x squared. Okay?
Okay.
Now, in terms of a graph, this is the slope. And so what happens when the slope is 0? The graph is
0. Oh, wait.
horizontal, right there, right? That's where the slope is 0, isn't it?
Okay.
So what happens when the slope is 0? It has a horizontal tangent line.
Is that all of them?
Every time the derivative equals 0, guess what happens? You have a horizontal tangent line. Every time the derivative is positive, it is increasing. Every time the derivative is negative, it is decreasing. When the derivative is positive, what's the function doing? It's increasing. When the derivative is negative, what's the function
So when
doing?
the slope is increasing, it's positive.
Exactly. When it's
Okay.
positive, the slope is increasing, and the slope is the rate of change, right? So if the slope is positive, it's increasing. If the slope is negative, it's
Decreasing.
decreasing. So there was not a whole lot of math involved in that, but more of an understanding of what it means.
Okay.
First and second derivatives, you want to do those? Or are you happy with them?
I got them.
You got them? The only problem is the radicals. So this one, the first one is t to what power?
2/3.
T to the 2/3.
And then
The second one is 2t to the
3/2.
3/2, because your root, again, why do they have a 2 there? I don't know, but they do.
They're really ticking me off.
I know, it's like,
Okay.
make sure it doesn't have a 2, put a 5.
All
This
right.
one is 4t to what power?
1/2.
Minus 2t to what power?
Negative 1/2.
And take your derivatives. This one doesn't have a watch it, but I figure by now you've done so many of these
Yeah.
that, you know,
I've
just
got it.
practice.
That's one thing, I have to repeat doing it to understand it.
I'm telling you. Okay, so I'm going to stop this video and then we'll go back and look at some of your other problems you had some questions with.
Okay.